Thank you. Thank you very much, Pavel.
No worries. And Maxim, the stage, I guess, is almost yours.
Yeah, we just have to see if the technique is working. And I think I will have to do it without clicker, but the stage is cozy enough that I don't have to, like, I'll just walk to the, my laptop. And, okay, so we can see. Okay, yeah, welcome. So I'm very excited to be here today, and also thank you very much for inviting me and coming to this talk. And I will talk about ECS pattern, and I will try to explain what it is and what are the main things about it. So, as already mentioned, my name is Maxim Zaks. This is my Twitter handle. Please don't ask me why, because it was like long time ago. And yeah, so before I start with the talk, I would like to talk a little bit about myself, because some things that I will be talk about might be like feel a little bit weird and outrageous, and I just wanted to show you that I don't just talk about it because I just learned something new, but actually those are things which I was practicing for a long time, and they work nicely for me. It doesn't mean that it will also work for you, right? But I just wanted to share my own experiences and what I like about this stuff. So I started programming when I was 14. I think my first proper programming language was Visual Basic. Again, nothing that I'm proud about nowadays. But you know, it's kind of, you're young and you're just trying stuff out. Then 2007, I actually graduated university with computer science degree and started working professionally. And then I did lots of different things. Actually Java development, then tool development, then web development, then iOS development, then game development. And in 2012, I started working at a gaming company where I actually came across this thing called entity component system, which I will be talking about today. Okay, so again, it's nothing that I just learned. It's actually something which I practice for over 5 years now. I did it in game development and also adapted some of this stuff into iOS development. So what about you? I would like to get like a little bit of knowledge of people who we have here. Who considers yourself as an app developer? Most of the people, actually, right? Who did some game development? Maybe 4, 5, 6 people. Okay. Who heard about ECS, entity component system? Almost the same people who did game development as well. Okay, cool. So, as you might already understand, like the entity component system concept comes from game development, actually. And if I want to know something about stuff, I go to Wikipedia and there's search for it. And I don't want you to read all this stuff. It's actually not necessary. The interesting part is actually that the first notion of ECS pattern was in '98, so 20 years ago. There was the first game called Thief of the Dark Project, which used this pattern. And again, like actually why I like to bring up this page with Wikipedia, because the author of the article actually confused two patterns, entity component system and more like component-based entity component without the system. So the article is actually a little bit wrong, but still I think it's important to see some historical parts of it. So I would still recommend to read through this article to see how it actually started and what are some opinions about this pattern. not only my opinions, right? So what is an entity component system? What are the main concepts? It's actually the first and the most important one, in my opinion, is you separate state from behavior. And this concept is already quite different and outrageous because it stands in direct contrast with object-oriented programming, where we say we have an object which has properties and it has methods, and actually these methods should work on these properties. This is what we call cohesion in object-oriented programming, and we should actually strive to higher cohesion while we're designing our classes. With ECS, we actually say like, okay, no, we're actually separating those two. We say we have a thing which represents the state, and we have something which does the behavior, does the transformations. They shouldn't be coupled at all. The second one, and this one is even weirder, and I actually kind of realized that only like maybe a year or two now, that what you have with ECS as well is there is no message passing. There is no APIs calls in a way, because the representation of data is decoupled from the behavior, and what the behavior does is actually it queries the data that you need and transforms it. So the systems don't depend on each other. There is no API calls between the systems. By the way, if you have some kind of questions and so on and so forth, just you could directly just interrupt me and maybe ask questions. Okay? Cool. Right. So let's continue with the definition of things, right? So what is an entity? And there are as well definitions about it, and I like the 1B because it actually explains what an entity is from the entity component system approach, and it says that entity is the existence of a thing as contrasted with its attributes. So an entity is a thing, and we don't know what it is actually. It reflects through its attributes. So there are different implementation of the ECS pattern, and an entity is normally implemented either as some kind of a data structure, which is basically a bag of components, or sometimes it's just an ID, just a number. Again, now it's a little bit abstract, but I will walk you through to more less abstract examples. So what is a component? Component, I like this like bloomy and visual explanation. It's the alphabet of your data. Very visual and bloomy. Sometimes I also like to tell that components are atoms and entities are molecules. So if you put multiple atoms together, they form a molecule. And you could also like break it apart and create a different molecule from this. So components basically are value types, which represent something, but for themselves, they're just data. And you can put them in an entity or on an, like reference them through an entity, and then they form something. Okay. And the component can be just a tag, so I say like it's just a type with no properties, and it already explains like the it already categorizes the entity, saying like something is droppable, right? It's just a component, it has no properties, but you know if an entity has a droppable component, then this entity can be dropped, for example. Then you can have a component which is a value container, which has properties which are as well value types, or you could have a component which is a reference type, and then you can just say like, okay, I have a component which has a weak reference to a view controller. So it becomes, and I say it renders cats, for example. So I have a view controller which renders cats, and then I say like, okay, there is this component which has a property, and if I would like to get something which renders cats, I just say like, okay, give me all entities which has this render cats component. Okay? So to give you a little bit more like a typical example, like this is Swift. Who knows Swift? Half of the people, but I hope it's still readable, right? So it's just basically, here is a typical example where I'm representing a class, which is a person, and I say it has 3 properties: name, city name, and speaker, which is a Boolean, right? And here I am constructing myself. So to construct myself, I create a person which names is Maxim, city name is Berlin, and speaker is set to true. Okay? Now this is how it would look like with an ECS pattern. With ECS, I would like to decompose. As I said, the components are like this, your alphabet of your things. So a name is already something special, because a person could have a name, a dog could have a name, a conference could have a name, and maybe I have something which has to just greet something with a name. So I don't care if it's a person, dog, conference, I just say, give me everything which has a name with it, right? Pretty much polymorphic. So we say, okay, we have a name component which has a value which is a string. We have a city name component which has a value with a string. And we have this tag component speaker. And when I construct myself, what I do, I just say like, okay, context, create an entity, which is me. And now I'm just an ID basically, right? I'm nothing yet. And then I start adding things to me, my name, my city name, and speaker. And then I become a speaker with the name Maxim, who comes from Berlin. The interesting part is as well that those are components. I can also remove them. So, for example, today I'm a speaker. So if Pavel needs to see that speakers are there, he'll just say like, okay, give me everything with speaker component, and I know that I have to monitor them. Tomorrow, I'm not a speaker anymore. I'm still Maxim from Berlin, but I shouldn't appear in his search in a way, if Pavel would be a system somehow, right? So this is the flexibility that you get if you start decomposing things a lot. Okay. So what is the context? Basically, entities are managed through context. And like normally with classes and objects, they can be created unmanaged, right? There are somewhere managed through runtime and so on and so forth, but actually, like I could create objects without supervision, let's call it like this. Entities I have to create through context, so that can be supervised, and also context can monitor the life cycle of the entity. And also, some implementation give you a possibility to observe entities or a collection of the entities, saying like, okay, notify me if, for example, the collection of speakers have changed. For example, now I'm not a speaker anymore. We will notify Pavel to say like, okay, now you have a different set of speakers actually. So you can perform as you wish. Okay, so maybe to give it a little bit more perspective, let's compare it with relational databases, which is probably something that you are familiar with. And we could say that an entity is just a row, the component is a column, or rather the component type is a different column types, right? And the context is the table itself. Let's see here a simplified example where I say like, okay, I have a simple table where I have Maxim from Berlin, who's a speaker, Kate from London, not a speaker, Alex from Amsterdam, not a speaker, Lily from New York, speaker. This is kind of like, this would be the whole context. We have these 3 components, and we have 4 entities which we composed and created something. The interesting part is, in relational databases, we have schemas, because we need to persist, and we should be able to have only simple types. With ECS, it's also can be seen as in a way as a database, but schemaless. Your schema is basically your type system, and it's only at runtime. Persisting of entities is generally a different problem, and it's orthogonal to the ECS itself. Who happened to see this talk? One person. It's a talk from 2014 by Mike Acton at CPPCon 2014, right? And it's called the Data-Oriented Design and C++. What I like in this talk is, actually the talk is really great, but it's also gets really technical, and it's also really long. It's like 90 minutes. What I really like is this definition from Mike, where he says, the purpose of all programs and all parts of those programs is to transform data from one form to another. Who disagrees? One person disagrees. Like, I think actually it is universal, because, like, to be honest, when I was a consultant doing Java in financial sector, I thought it was really boring, because like at some point I identified what I'm mostly doing is reading data from one database, transforming it a little bit, and then just pushing it into another database. This is the whole thing, right? Reading, transform, store. Backend work, right? Not interesting. Okay, front-end work. If you think about it, we take, like, for example, you're doing web. You're taking HTML, CSS, JavaScript, and then at some point it will be transformed to an array of pixels. From a high-level perspective, it's still just the, data transformation. The transformation is more complicated. You have lots more, like, substates in a way. But anyways, if we're doing iOS applications as well, it's just at the end, we just creating an array of pixels which will be shown to the user, so that they can, like, put some input, and we'll react to this and show a different array of pixels on the screen. So let's talk about systems. So systems are the things in ECS which actually do these transformations. And they do it as following. They query for data they need, and then they transform this data. And here, it's actually quite easy to implement single responsibility principle. Because if data is represented already, you can decide how much data you need to actually achieve this transformation you would like to do. So a hello world of typical ECS is actually so-called move system. What it does is we say the system will just ask for all entities which have position and velocity component, and they will exchange position with a sum of position and velocity. This is it. Very simple. You can write it almost in a one-liner. But this is the whole responsibility of this system. The system doesn't know what it actually moved. It doesn't care. It could be a house, it could be a person, it could be a bullet, it could be whatever you want. If this thing, this entity have a position and a velocity, then it has to be moved. And it also has no responsibility about rendering this. This is in a pure logical state. So logically, it has to be moved. There will be another system which might need to render this thing with position and then maybe a reference to some kind of a 3D model or sprite or whatever to actually to turn it into array of pixels in a way. But this is a different responsibility. Okay? So that I already mentioned, that it doesn't care about the properties that it has otherwise. And it reminds me of this story. Who knows the parable of blind man and the elephant? Nobody knows. Okay, so it's a parable which is, I think, the roots are actually in India, and the story goes a little bit like this: that there is a king who invites lots of blind people, puts them in the place of an elephant, asks them to touch the elephant in different places because the elephant is huge, right? And then he asks the blind man to explain what an elephant is. And there are actually two ways how the story ends. And one way they start fighting because this person here has a complete different idea of the elephant than this person, right? There is another ending where they start helping each other, and then they kind of try to understand what this concept of elephant actually is. So in our case, with app development or game development or whatever, the elephant in the room is actually your state. It's big, it's complex. You don't, and to understand all of it is really hard. But the system which works and does the transformation doesn't have to understand all of it. Doesn't have to see all of it. To, for example, like clean the foot. You just need to understand what the foot is, so only a part of this state to be able to transform it, to be able to work with it. And this is kind of like the general idea which you have in this decomposition in the entity component system way. Okay, I would like to do a little bit of an, not showcase, but just general idea, how would one write a networking service in an object-oriented way and in the ECS. This is not a typical example, like normally you would do something different, but here I think specifically for us as app developers, this use case is kind of like familiar because we do networking all the time mostly, and it still showcases how the way of thinking is different here. So typical OOP implementation, I would say we have like a networking class which exposes endpoints as methods. Who does something like this? A few people. Yeah, most of the people. Okay. And then the method either receives a block callback that it can call when the request went through, or we have some kind of a promise which we get, and then this promise has these callbacks which we can add on success, on error, and so on and so forth. This is a typical example like how it would work in object-oriented way, right? And networking class has actually quite a lot of responsibilities. Like you could break them down basically, I totally agree. You don't have to have this one God class which, but the networking is kind of your level of abstraction, right? It's the abstract thing which does URLRequest construction, right? It sends the request, it waits for response, it deals with error, it transforms the payloads, and all of it, it's either in one class or in this hierarchy which you have, but it's basically somehow for you, it's this one black box which you're just using in a way. And this is only the one thing. That there is a second thing which is kind of like more obscure, and it's logging and some kind of request management. Because sometimes you would like to say like, if I kind of already request is in process, I would like to wait for it to process before I send it again. so that I don't spam the backend, or you say I have authorization, so if there is a request incoming and I'm not authorized yet, I can actually avoid sending the networking call and so on and so forth. Not necessarily, right? But in some cases, it's actually needed to have this kind of management. Also in this networking class, having some kind of queues and so on and so forth. So let's try a more data-oriented approach. How would it look like in ECS? Not necessarily like just an example to have a contrast between two ways of thinking. So in ECS, we start at the bottom. We just think about what kind of data do we have actually. Not like this abstract thing, we have this networking with endpoints, so endpoints are methods. But we say like, okay, what we actually have is a base URL. We probably have some kind of URL components which will define the endpoints. We have a HTTP method, get, posts, whatever. Then we have might have parameters like HTTP parameters or URL parameters, and we have request payload, which can be JSON, XML, whatever. Right? So we define like this is the data which we can put into an entity to represent this call, which we would like to do. Okay. Then as well we have response data. We say this is HTTP status, internal error codes on messages. Like for example, we don't have like internet connection, so this is not even HTTP, but something from the operation system. And then we have this response payload, which we would need to transform into our like business logic model. We have also some useful information for logging and request management. Timestamps to say like, okay, this is when the request was performed, and this is when the response was like received, right? With this, we can actually do nice logging, specifically if we have some requests which take a little bit longer. This is a meta information which is sometimes useful, but it's actually a nice thing to have specifically on an entity which goes through transformations and stages. Then we could also say, like for request management, we could have like thread IDs or different other breadcrumbs to understand how does this request actually come to be in our case. And it's literally application specific. So what are the transformations which we would like to do? So if we, like here, I'm kind of like pointing more into iOS, where we have this class called URLRequest. And we could say we have a system which finds entities which have all this request data which we defined, like base URL, URL components, HTTP method, and so on and so forth. And we create this responsibility of this system is just to create URL request. This is it. And we also say like, okay, we have a URL request component which holds a reference to this object in our case, right? Then we have this send request system. And here we say like in iOS, we say give me all entities which have this URL request component, or just give me the new ones if your context can be observable. And then you just say like, okay, I have a URL session and I will create a request for this URL session. And when it's done, I will add a URL response component, which will have like reference to this URL response object. Or if there were problems, I will create a request arrow components. So if I create a request arrow components, I have a system which with single responsibility, which can just say like, okay, give me things which help you request arrow component and do something about it. And what you do is basically on you. You could also have like multiple systems which do something like maybe one system shows like a warning or a spinner or something like this. The other tries to do retry. If we see like, okay, the error is basically that the internet connection is flaky or whatever, right? And it's, again, it's a single responsibility principle. The system does only one thing, dependent on the data it finds in the entity itself. Then, if the request was successful, we could just take the payload component and just transform it either into new entities or change existing entities, right? And it's, again, it depends on your actual business logic, what you would like to do, but the responsibility is quite clear in this regard. And again, if the transformation failed, you can create an error component, add it, and then the system which is responsible for errors will do its dirty work to actually like either notify someone and so on and so forth. Then timestamps, we could either have our own system or just say like, okay, maybe it's better to have these components added when we actually in the send system. But you can think about like here, how fine granular would you like to have your responsibility? How fine granular would you like to break down your behavior in this regards? Then show warning for slow request systems. You can periodically check if entities have send time and no receive time. And you can also define, like, after a couple of seconds, it seems like the request is in nirvana, so it's kind of like a, maybe not a timeout yet, but maybe something that you would like to show the user, so it takes a little bit of time. So that maybe they should check the internet connection and so on and so forth. Again, these kind of systems you can add, you can remove. They are completely orthogonal from each other. They don't know anything about each other. They all work on the state. They just think about like, okay, I have one transformation that I do, and this is my responsibility. And you can add them and remove them quite easily, because they also don't have any dependencies and API calls to each other. Right. Then you could also discard request. This is kind of like management of requests. If you see that you have an entity with the same request data, which is pending, and you got a new entity with just exactly the same request, you could have a system to say like, okay, I will drop the new one because what's the point? We're still waiting, therefore, simple responsibility of a simple system to do a simple transformation. Just drop an entity. Cleanup request system, again, you could say like, okay, I could actually keep the old requests around because they are just data. They don't do anything. For I have like historical reasons where I would like to maybe see how much time it took like in previous requests to do this. Or maybe it's just unnecessary, so I will clean them up if I see like, okay, the responses got added, I already transformed the payload into something else, therefore I can just delete this request entity altogether. And again, like the interesting part is, as we have everything as data and it's exposed, the logging can be also completely orthogonal. I don't have to add logging inside of existing systems. I can have them as a separate systems, which just query for things and just do the logging. So if I want to log, I do this. It's also, if I don't want to log anymore, I just can turn off the systems and I'm good. So there is no entanglement of logging logic and our transformation logic, or our logic which does like view representation. So in a way, who heard about aspect-oriented programming? few people. So the main idea is basically to say, with an aspect, you can describe a method. It can be on different objects, and I would like to kind of like inject myself before this method was called and after this method was called. This is something that you can do in Java and C#, and there are also other languages and frameworks which let you do this kind of magic. But with ECS, you actually don't have to do this because the data is anyway separated. You don't have to intercept on the method calls. You just can say, like, if the data changes, please notify me, and I will do this specific aspect which I would need to do in certain cases. And also, like, you can easily have like feature flags to say, like, in this case, those systems work, and in the other case, they just don't work. Right. Like transform UI element, UI event to request data system. I told that we have this for creating URL request. We have this request data, right? Base URL, method, and so on and so forth. So what we could do, we say, like, we have this button event, and we could just directly create an entity with all this data. But this might repeat itself multiple times. So what we could do is, again, we could just separate it and say, like, I have actually one component which represents the action, or UI action, or UI event, which I create. And then I have a system which does the transformation from this more abstract UI event into the request data which I need. Make sense? All right. So here is a small diagram how this data kind of flows. You can have an event component which will transform to request data components, which then triggers the request timestamp component, creation of request timestamp component, or an error component if something goes wrong, and then we get this response data component, which again comes to the timestamp, and we have these new entities when everything is done. So all these edges are actually system calls. Those are the transformations which we have. If we have a system which transforms this state to another state, this is actually how it works. And if we would like to have an offline application or a mock, what we basically have to do is have a system which goes from here, from this data, directly to this data, and bypass all these transformations. But again, it's completely decoupled from one thing from another. It's just systems which we can introduce to do this stuff. Like, I have an anecdote. I worked on a game where it was an online-only game, and like the project was stopped, and we still wanted to preserve the game as long as possible. So we switched from online-only to offline-only in 3 hours. Because this is basically, as we implemented it with ECS, it was very easy to bypass some transformations, to just exchange some systems, to just store the game state to the like hard drive, or you don't have a hard drive on the mobile, but to your phone, and not send it to backend. Okay, so like what I would like to stress is actually, like, ECS is not just a library, it's actually a way of thinking. Right, because it's completely different from how we normally build up systems and build up like business logic, application logic, and so on and so forth, even rendering logic. So it is bottom up versus top down. As I try to show you on this networking example, in object-oriented programming, I would start with the highest abstraction, saying, like, I have this network which has these methods, and I will go down. here I actually think about, okay, what is actually the data I have? So I start bottom up. I just try to understand what are the small things, and then they kind of shape the whole application logic. It's also a thing of, in ECS, I would say we have a level of detail and not level of abstraction. We try to avoid abstraction as much as possible because we would like it to be data-oriented. We would like to understand what data we actually have. Not this abstract concepts of saying like, I have a person, I have a network. The question is, if I see a person class, what is it? It can be anything you want, but if I say I have a name component, I guess everyone can understand, okay, name, yeah, name. Like I worked as well in financial sector, and what is interesting, people like to have an, like in object-oriented like books, they like to do zoo, or they would like to do like account, financial account. The funny part is, if you work for banks, you know that account, there is no such thing. Account is actually a product which every bank invented for itself because this is what they sell. And they would like to also evolve on this as much as possible. So if you try to have like, define it as something physical, to say like an account have an owner and it has a debit and credit, there are accounts which have no owners. There are accounts which have multiple owners, and so on and so forth. Like it's really, it's all about data, because you actually, what you need to store is the data, and you should be able to transform this data. And it doesn't, like, in my opinion, again, it doesn't always like transforms into this kind of abstract way of thinking. I personally believe that state is not your problem, even though there are multiple like schools which try to demonize state, saying like this is the pure evil. I think like actually, in a way it is, but it's also a fact of life. Our applications just work because we have state. Our interactive applications like apps, they basically work in a loop. If we wouldn't have a state, we wouldn't be able to like actually continuing and having some interactions. In my opinion, hidden state is the problem, because you have a case where you actually, you know there is state, but it's hidden from you, so you don't have all the information to actually to make your work possible or at least pleasant. Because, for example, with this request, I have, for example, I have a closure which actually encapsulated some states, and I won't be able to actually understand, okay, maybe this request is already stale. I would like to change it, but I have no way of actually kind of know what happened. I don't have enough information to make my educated guess about this. Right. What I personally like about ECS is basically that it's easy to implement new features. When you're implementing new features, you just look if you have enough components already, or the feature implies that there is more state that you have to reflect. And then you add some systems, and basically you're done. And it scales horizontally. The systems are not working on top of each other. They are placed like horizontally, so they are all doing their thing, and it's easy to replace them in a way. It's also very easy to test, because generally, if you would like to test a system, you just create a state that you need, run the system, and see that the state which resulting state reflects what you would like it to be. As we don't have any information hiding, you can assert on anything, because it's just a basic transformation. And it's also easy to clean up and to replace. If I see like I have these 5 systems and I think like, okay, it's actually not that performant to have 5 systems, I would like to have one, a beefy one, which has multiple responsibilities, but it will be more performant to do it like this. I can try it out, and I can have them basically in parallel with a switch. To say like 5 systems, 1 system, one time I turn this 5 on, one time only this 1. Everything works. If I decide that this system is actually more performant, I will just remove those 5 and keep this one running. And for me, it feels like prototyping while maintaining production quality code. So it's because it's easy to add features, and because it's easy to replace, and because it's easy to improvise in a way, it feels much more, I personally feel much more productive with this pattern. So who else uses ECS? How am I in time actually? Okay. I'm almost done. There is this small company called Blizzard. Who knows them? Some people, they do games, and like it's always a little bit hard to tell what they actually use internally, but they had like a couple of talks by developers, and at least Hearthstone and Overwatch is done with a design as I explained it to you, so with entity component system, and those are very complex applications. Then there is another less famous company which called Wargaming.net, and they had a really fun blog post where they said like they rewrote the engine 3 times before, because each time there was a new thing that they explored and saw like, okay, with our current class hierarchy, we can't express it anymore, so we need to change the engine. And then at some point they switched to ECS, and at least for a couple of years they were without any rewrites. They could concentrate on actually writing games and delivering the games. Then as well, Unity is currently, last year they announced this performance by default slogan. And like Unity actually had performance problem. It's a really nice engine, but there were a couple of issues. Specifically, if you would like to write games for consoles, it was much trickier to write something there. And now they kind of addressing this, saying performance by default, and they doing it basically through these 3 things. They introduced a new job system, they switched to entity component, and they introduced a new compiler. And with entity components system, they write following: a better approach to game design. ECS is a way of writing code that focuses on actual problem you are solving, the data and behavior that makes up your game. In addition to being a better way of approaching game programming for design reasons, using ECS puts you in ideal position in leveraging job system, burst compiler, and so on and so forth. So actually, they also mention this thing where I disagree a little bit. They say that with ECS, we are moving from object-oriented to data-oriented design. I totally agree with that, which means it's easier to reuse code, easier for others grasp and contribute to it. Like, actually, this reuse thing, I slightly disagree, because there are actually multiple ways to understand reuse. In one way, like in my gaming projects, which I did, we actually reused code by having the game logic extracted and running on the client and on the server. So we reused this logic because with ECS, for us, it was easy to represent the game state and the systems which are just logical and decoupled from rendering. We had systems which do just logical things. You might call it business logic. And we had systems which do the rendering. So on the back end for validation, we could just take out the logical systems and put them on the back end and run them for validation on the back end. But normally, there is another thing about reuse where you say you create a generic component which you can reuse in multiple projects. In this case, I think actually object-oriented programming is better. Because there you kind of think about like this abstraction and top-down approach. You say like, with our example with networking, we say like, I have just this networking class, or let's call it a login module. This is the last one. And then I don't have to know the details. I don't have to know how the internals are. With ECS, as you're decomposing, you have to know the alphabet, not only like the full sentence. To say like, I need food. Like, I don't have to understand what like the actual things is, but if I say I need food, people will give me food. I'm okay with that, right? In ECS, it's more about you have to understand actually the components and all this decoupled thing, how they work. All right, so I will skip this one and let's do a conclusion. So conclusion is with ECS, I actually didn't talk about it much, but it's also the key point of Unity to switch into ECS. It is possible to achieve a very high throughput because when you define, when you decouple behavior from data, you also can represent your data in a way where you can achieve high throughput because of some CPU advantages and so on and so forth. And you can also think about like how you will design a system from a performance perspective, not only from a single responsibility perspective. This is basically up to you, but as it is decoupled, it's easier to reason about different stuff. For me personally, and this is why I also came to this pattern, is because it gives me a very flexible pattern for logic and state decomposition. And it gives me like lots of freedom to add new features and kind of reason about complex behaviors and also easily unit test this. And with this, I'm done. Thank you.